Welcome to Brain Vision.
So we must find the angular displacement in the first 2 seconds, how long it took for this entire thing to stop, and then the total time. So it would be, we would first write down our givens. The initial angular velocity would be 24.0 radians per second. And then we have alpha equals 30 radians per second squared. And this would occur from 2 seconds, because at 2 seconds, the wire trips. And actually, you can do like that. So we can say that this is at t equals 0 seconds. And then they want us to find the angular acceleration from 2 seconds to the end of the to when the wheel stops, essentially. And we also know that delta omega is 532 radians, but this is only after t equals 2 seconds. So we should say, well, we have constant acceleration throughout, so we can use our kinematic equations applied to rotation, or rotational kinematic equations, essentially. So this will be theta f equals theta initial plus omega initial t plus half t squared. And then we can say omega f, we can actually take this to be 0, and then we're going to try, this is going to be for the first 2 seconds. So we can say omega initial is 24, this t will be 2, and then plus 1 over 2, 30, 2 squared. And this is going to be 108 radians. So this would be first 2 seconds. And then if you wanted to find total, it would simply be 108 plus 432, so 540. And then we need to find how long it takes. So let's get a new workbook. We'll start off by using this equation. We don't know how long it takes, but we should try to find the angular acceleration after 2 seconds. So we can say 2 omega delta theta. At this point, let's solve for angular acceleration. So angular acceleration would equal minus omega initial squared all over. Here, our final is going to be 0 because we are stopping. And then our initial will simply be equal to the final velocity after 2 seconds. So we can't really apply this yet. We can say that this, put a little star, and we can say, so this is going to be 24 plus 30 times 2. And this is going to be 84 radians per second. And this is the value that we're going to use for this. So we'll have negative 84 squared all over 2 times 432. And this will equal negative 8.167 radians per second squared. So this is actually C, but it's much easier to find C first and then find B. So, and at this point, you can just say, okay, use the same exact equation. However, now we're doing it from 2 seconds to t final. And then here we can say, okay, this is going to be, we know that this is going to be 0. So we can simply just do negative omega I over the acceleration is going to equal t, negative 84 over negative 8.167. And this is going to equal 10.3 seconds approximately. So our time total will equal t plus 2 seconds, or 12.3 seconds. This is your answer for B. So the entire thing takes 12.3 seconds. It travels a total of 540 radians, and then it comes to a stop after t equals 2 seconds in 10.3 seconds with a constant angular acceleration of negative 8.167 radians per second squared. And that's the end of the solution. Thank you for watching.